Hello and welcome to the final topic in this Unit 3. Today we're looking at the application of regression and some critical analysis. So the learning goal for today, I can apply regression, so that's what we've been talking about the last couple of lessons, to real-world situations. And then this is the newer, the challenging part, is analyzing the resulting regression and drawing appropriate conclusions. So this is kind of where your statistical skills come in terms of the project and your critical thinking skills. So some people are going to find this a challenge. Some people are going to find it difficult, but we'll be able to kind of get the gist or the feel for what the expectation is. So you have all this in front of you. We see programs, whether it's news or social media, that have stories, and they put statistics in there for us to support their arguments. Now, you got to be very careful because the media uses it to shape public opinion. And I'm not saying that the media is malicious or trying to twist us to, to come around to believe what, they want to believe, but the statistics can easily be misinterpreted when they're being presented, or for someone that's not familiar with statistics, they can look at a piece of statistics and draw the wrong conclusions. So it's important, and the focus here is to make you a critical thinker and to, take a step back and say, well, how valid is this set of data or set of statistics? So the following examples, they're just going to give you a guideline to take into account in the homework, but also when you do the project, and this is going to be key when you're actually going ahead and doing your independent study. So there's three areas that I'm going to focus on today, and that is the first one, sample size and technique, to show how changing the sample size, changing your sampling technique can really skew your data. I want to talk about an extraneous variable and sample bias, and then finally that hidden variable. So there's three examples that are going to touch on each one, and like I said, it's going to be more challenging for you in your project because you've got to take a step back and figure out, which of these may apply to the particular situation, or in, the media or whatever piece of data you are looking at. So the example I want to start with is the sample size and technique. So the question is, a manager wants to know if a new aptitude test accurately predicts employee productivity. So companies will provide written tests sometimes, and it may be, simple skills questions, math, English, etc., or it could be related to the workplace. But it's not uncommon to have these aptitude tests, especially if you're applying for a job. The manager had all 30 employees in the company test and compared the scores to their observed productivity. So if you're in a job, you get performance appraisals every year, and that's kind of how they gauge your raises in the real world. So he's taken those aptitude tests that they took originally and comparing them to the productivity reports that his manager or whoever is assessing it is giving him. So the employer arranged the data, collects it alphabetically by employee, so the data is sorted, and that's provided below. I was just kind of, it's not so overwhelming here. So the manager decides that he's going to do a systematic sampling technique, and he's going to pick every 7th employee on the list to analyze. All right. So what that basically means is he's going down and saying, okay, here's 1, 2, 3, 4, 5, 6, 7. There's another one. 1, 2, 3, or sorry, 2, 3, 4, 5, 6, 7. So he's picking every 7th employee. Whoops, that one's not in the right location there. And by doing that, he's picking an appropriate strategy, a systematic approach to it. So 2, 3, 4, 5, 6, 7. Move that down a bit. 2, 3, 4, 5, 6, 7. All right. And that's the data that he's going to analyze. So based on the data, the manager concludes that the company should only hire applicants who do well on the aptitude test. So that's his gauge. All right. So what we're going to do is we need to determine if the analysis is valid. So again, in Google Sheets, I have provided you with, if you go to lesson 20, the pre-made spreadsheet. So all the numbers are already in. So if we go down and do every 7th, so I'm just going to quickly change the color. So I'm going to pause it for 1 second, do this. Okay, so I've gone down my list here, And what I've done is I've highlighted every 7th one. So this is the one the manager would have taken. So what I'm going to do is I'm going to play a bit of a copy-paste game. So I'm going to copy and paste my yellow numbers over here. So I'm just simply copying and pasting my values because I want to isolate the data that he analyzed. And so the first thing I notice is that out of 30 employees, he only analyzed 5. So on the next page, I left some blank space. I'm going to put that in. So, oops, too big. So I'll just put analysis up here. I'm going to add some thoughts as we go. So my first thought here is the manager only used 5 pieces of data out of a population of 30. This is what I would say is relatively small in order to draw valid conclusions. You really need, if you're going to make a sweeping policy for your company, I would say that the amount of data he chose is not really appropriate. So if we go ahead and do what we've been normally doing, let's do a regression analysis here. So insert the chart, again, more, scatter, scatter, customize. So chart title, we would have test score versus productivity. Legends in the right location. On the horizontal, we have test score. Oops. And I realize the title's backwards. It should be the other way around. Productivity. And I mean the min and max, I am going to go 0 and we'll go 100. And the horizontal, same thing, 0 to 100. Okay. So my first analysis, when I look at those 5 points, I am saying, that is not overly impressive in terms of regression, and I'm going to put that. So based on the manager's chosen data, there appears to be a weak positive correlation. So this is kind of my thought process here. And let's get an R value for that. And I'm not even sure what we're going to actually use for an R value, just based on what we're looking at here. So if we go down and put a trend line in, if we try linear, put an R in, I mean, we're looking at, like, that's virtually 0, because remember, exponent -3, so that's really 0.0031 for an R value. I don't even know, exponential doesn't change it. Look at the polynomial. It's a little bit better, but it doesn't make sense. The lower your test score, increase productivity. So I'm not even sure what this manager used, but according to our data, we're looking at a virtually 0 correlation. So I'm going to say our R value. So even if I put that in the calculator, if we want to be completely accurate, 0.03, that's like a 0.05. Like that's no correlation. So essentially, no correlation. All right, so that's what I take from that. Now, how did he make it look perhaps a little bit better? This is probably what he did, and I'll show you how this changes things. So let's go to 60 for a minimum on the horizontal. All right, if I go 60 on the horizontal, and let's go 40 on the vertical, and watch what happens to the graph. Okay, all of a sudden, when you zoom in on a particular area, and if you ignore this trend box, so if I get rid of that for the moment, so let's get rid of trend line, none. Look at what happens. The data looks like, there actually looks like there's a bit of a relationship. This is maybe an outlier. If I took that out of the mix, look what happens. So if we took that out of the mix, for argument's sake, that one right there. So if we take that out of the mix, now I'm down to 4 data points, which is even getting more ridiculous in terms of drawing conclusions. And look what happens to the results. So let's go back to trend line now. So again, all of a sudden he starts saying, this looks pretty good, but he zoomed right in. But if we put an R value to that, now we're even, it's still virtually zero. It doesn't improve it. So what probably they did was he just looked at what the points were and said, that does look like it is some form of linear relationship. So that being said, I'm going to insert that graph just to reference it. But what's happened is he hasn't picked enough data. Now you want to see if I pick other components of the data, it would change the results. All right. So I would say for myself, recommendation, all data should be considered when the population size is small. All right, so if we use all the data, and the nice thing with spreadsheets, it's not a challenge. You just got to highlight all the data. So here we go. Let's see what it should be based on everyone's results here. So if we make our scatter graph, customize it. So, oops, productivity versus test. And horizontal, we'll start there. Let's go, that's test score. And again, I want to go from 0 to 100, just to get a feel for it. Changing my vertical, productivity, 0 to 100. And now when I look at it, there doesn't seem to be, if anything, it's going to be a horizontal line. That would be my guess, because the data, it's kind of just all in one kind of square region there. So if we go down and just do the analysis, if I do a linear through there with an R value, it's still really, really small. And I mean, you can't say all of these are outliers. I mean, that's eliminating a sixth of your population as being outliers. So, I mean, the conclusions here for myself, if I'm looking at this, is that there's no real relationship between them. So, including all the data, no real relationship is visible. That's again, R is still really small, so I'll say it's definitely less than 0.1. Okay. Now, what are the reasons for that? All right. What are some of the reasons? And that's the important part here is, why is it like this when we're talking about productivity versus test scores? And I think the conclusions are pretty simple, or I shouldn't say they're simple, but the first one I would notice is that, work ethic and test taking ability are, not related. You could be a hard worker and your work ethic in the workplace has nothing to do with your ability to do test scores. Also, maybe the test material is unrelated to job requirements. Okay, if you're working on an assembly line and you're trying to do some more challenging English and math questions, or maybe you're in an accounting office and they're asking you, how would you handle this leadership role? And maybe they're looking for their leadership questions that don't really affect, your actual role, current role. So, I mean, you got to be very, very careful because if you just take a snapshot and take a look at the picture, you might be misled. And like I said, if you narrowed this region down, if he was playing with or didn't adjust it appropriately, if he was looking at, say, 50 to 100, and well, even that makes it worse. So you got to be very, very aware of, there's different outcomes based on what you see. All right. So again, population size is very, very important. You got to decide, if you only have 5 pieces of data, how valid, is your results. All right. So that's the first example taken care of, and we'll move into the next example in the next video.